Hi, today our group will be giving the demonstration for our project Save It. I would like to introduce our group members again, which include a total of 4 people: Pravindu, myself Arshid, Ravindu, and Hamza. The tasks have been divided among the members equally. Pravindu took care of assembling the hardware and typing the code for the project. Ravindu covered the user stories and the system features. Myself, Arshid, had to create the timeline for the project and assign story points to different tasks in the burndown chart. And lastly, Hamza created the Trello board to break down the project into smaller tasks and components for each member to work on.
Hi, my name is Prem and I will be going through an overview of our project. The Sense Think and Act paradigm of our project is as follows. For the sensing part, we will be using three different kinds of sensors: motion sensor, lux sensor, and temperature and humidity sensor. We will be using four IR motion sensors, one lux sensor, and one temperature sensor. These sensors will be used to collect information about the surrounding of the room. This data will be then used in the thinking process of our system. For the thinking process, the motion sensors will provide data which the system will use to detect if whether a person is entering, exiting, or moving within the room. The lux sensor and the temperature sensor will measure light intensity and temperature respectively. These sensors are only triggered if it has been determined that a person is present in the room. For the acting part, our system will act upon lights, ACs, and heaters. If the light intensity is below a certain level, the lights will switch on, and if the temperature is above or below a certain range, the AC or the heater will activate accordingly. These actions will only occur if there is motion within the room. Moving on to the Trello board. As you can see, we have broken down our Trello board into three parts: the requirements, the prototype implementation, and the testing. In our requirements, we have listed the required sensors, the hardware components, the codes, and also the research for our thresholds in the room. We use this research to make our system much more realistic when implemented. For project implementation, the temperature and humidity data is recorded and analyzed, as is done with the light intensity data. After analyzing this data, we will be using it to determine whether there is any need for a light or a heater to activate. For our implementation of the prototype, we will be using LED lights to represent the appliances that our system will be acting upon. These LEDs will switch on and off according to the environment around them. For testing, we will be testing our system code with modules. We will have a module for our motion sensors, temperature sensor, and light sensor. And we will be testing each of these sensors separately to see if they work on their own as intended. And then we will be compiling our code into one and testing our system together.
Hi, I am Ravindu Vijay and I will be explaining the user stories and system features of the Save It system. The user stories consist of two users, the client and the designer. The purpose of the user stories is to explain what the user requirement for the system are. Firstly, I will be explaining the client stories. The client wants the system to switch on lights whenever the light is below a certain level and the system to switch off lights when not needed. Next, the client would require the system to automatically switch on and off the fans and ACs to control the room temperature. Moving on to designers' user stories, the designer wants to create a system that reduces electric usage and a system that is convenient to the user. Moving on to the system features. The system features are switching on and off lights, ACs, fans, and also automatically controlling the AC temperatures and fan speed. Another system feature is the ability to sense motion in a room.
Hi, my name is Syed Mohammad Hamza, and today I'll be demonstrating to you the system prototype system that we have created for our group project. So I'll begin by explaining to you the whole prototype system that we have created. So as you can see that we have used five sensors in our system. Three of these are motion sensors. One of them is a light intensity sensor, and the other is the temperature and humidity sensor. We have also used three LED lights, which will be representing our appliances in real life. So now I'll begin by explaining how our whole system actually works. So first of all, as you can see that this is a motion sensor. So this I'll call motion sensor 1, and this I'll call sensor 2. So sensor 1 will be placed right outside the door of the room, and sensor 2 will be placed inside the room right next to the door. So that means if someone walks inside the room, first this sensor will detect motion from outside the door, and as soon as someone enters the room, sensor 2 will detect motion inside the room. That means this will indicate to our system that someone has entered the room. So now this motion sensor will actually be placed inside the room. In real life, in our real project, we are actually going to be using two motion sensors, but for the sake of our prototype and our project, we are only going to be using this one sensor to show that if there's motion inside the room. So if someone has entered the room, or if motion is present inside the room, our system will check for the readings from these two sensors. So if the light intensity of the room is below a certain value, and if there is motion detected inside the room, or if someone has entered, this will indicate to our system that lights needs to be turned on. And the same is with the temperature and humidity sensor. It will turn on the AC or fans accordingly if there is motion and if the value of the temperature is above or below a certain value. And for in our prototype, those appliances will be represented by LEDs as I have already mentioned. So if there is motion inside the room and if the light intensity is low, this LED will turn on. If there is motion inside the room and temperature is below or above a certain value, so these LEDs will turn on to indicate that our system is working as it should be. Now, now I've explained to you our whole system, I'll be moving on to the next part, which is demonstrating this to you in real life. So I'll just turn on the serial monitor now. You can see. So I've turned on the serial monitor, and it should come up in a second. Yeah. So as you can see right now, the system is showing that system is currently off, and it's showing you the system that no one has entered the room, which means exited was the last state of room, and there's no motion detected inside the room. So now I'll try to create some motion here and see if this motion detector detects some motion. And yeah, it shows that now I have entered the room. As you can see, entered here. Heater is off, fan is off, the lights are off, and right now there's no motion detected by this sensor. But we can see that the motion we have entered the room. So it means that if I put my hand over this LED light sensor, it will turn on the lights. As you can see, the lights were off and now they're on because the light sensor detected that the value for light intensity is lower than it should be. So as you can see here, the LED is actually turned on, which means that there was motion detected and the light intensity was low. So as you can see here, the LED turns on. The same goes for the temperature and humidity sensor. The value that we have put in for the temperature and humidity sensor is actually 25. So it should, if it goes above 25 right now, that light should turn on. It's going up, as you can see. Hopefully it will go above to 25. It's 25, yep. So now the value has gone above 25, which is 26.5. And if you move on to our prototype here, you might be able to see that the light LED here is turned on. This indicates that our system is working perfectly, and if the temperature value goes up, the fans turn on. So as you can see that the LED worked when the value was above 25. Well, it still is above 25, so it still works. But it's the same for turning on the heater, but the value that we have defined for our heater is actually 15. So we cannot actually make it go below or to the value of 15, so we cannot actually show you this LED working, but it's the same with this heater process as well. So if the value of the temperature goes below 15 degrees, the heaters will also turn on. Right now, the lights are off and the fan is on as it should be because someone has entered the room and the value of the uh, temperature is 26, which is above 25. So I hope I've been able to explain to you our whole demonstration in a simple way. I'll end this demonstration by showing you that when someone exits the room, the whole system stops working. So I'll try to make some motion outside and see if it exits. Yeah. So as you can see now that our system has turned off because I have just exited the room and there is no motion recorded inside the room. So that means that if there is no motion, these two sensors, even if they're recording data, there's no need for our actuators to be switched on or switched off. So this is our whole project and I hope you like it.
Moving on to the challenges faced in this project. Some of the challenges we faced in this project are listed here. In a scenario where two people enter a room together and one person leaves, the system will detect this as an exited state. To fix this challenge, we have placed an extra set of motions in the room to detect movement that occurs inside the room. So if motion is detected in the exited state, the system will be updated and will in turn keep the system activated. If these sensors detect a substantial amount of motion, the system will be updated to the entered state. Another challenge faced was to minimize the wastage as much as possible. Therefore, we programmed the system to switch off if there is no considerable motion detected for 10 seconds after the system is in an exited state. So even any false positives detected will deal with only 10 seconds of wastage.
Thank you for watching our demonstration video. I hope you liked our project. Bye.
Khudafez.
Bye.
Bye.